Hey guys, Mr. Backberg here. In this video, we're going to look at a third derivative, which is also called jerk. So when we're talking about jerk, a sudden change in acceleration is called jerk. So say you're riding in a car with your friend, and your friend taps on the brake pedal and you spill your pumpkin spice cold brew all over yourself. Not only is your friend a jerk, but that sudden change in your speed or your acceleration there, that is called a jerk. And what the jerk is it's the derivative of the acceleration. So if an object's position at a time t is the position function s of t, so then that object's jerk at a time t is the third derivative of whatever your initial position function was. So in this example, we're going to be looking at free falling motion of an object. So an object is said to be a freely falling body if it's thrown or dropped vertically at an initial velocity and an initial height. So we want to determine the velocity, acceleration, and jerk for the free fall motion formula s of t equals -1/2 g t squared plus v sub 0 t plus s sub 0. Now before we go too far in here, I want to talk about what these things mean. S is our position function, so s of t is the position at a given time. In here where we see this g is the acceleration due to gravity. And depending on how you're measuring things, g can have a couple different values. If you're measuring things in feet, then your acceleration due to gravity is 32 feet per second squared. But if you're measuring things in meters, then your acceleration due to gravity is 9.8 meters per second squared. Now, v sub 0, that's your initial velocity. And s sub 0 is your initial height. Now, really, as we're looking at these, we don't need to know what those values are to do these derivatives to find the velocity and acceleration in the jerk. We just need to know that g, v sub 0, and s sub 0 are going to stand for some constants that you're going to be given in a specific problem. So if I want to find my velocity function, what I'm going to do is differentiate my position function. Now in here, as we're looking at this first term, we've got a couple of constants. -1/2 is a constant, but g is also a constant. It's either 32 or 9.8, just depending on how we're measuring things. So if we're looking at differentiating this, we're really focusing on this t squared as our variable, and we're going to have to do the power rule there. So we're going to have to drop this 2 down as a multiplier, and what's going to happen there is the 2 and the 1/2 are going to cancel each other out. So we're going to be left with -g times t. And then in the second piece where it's v sub 0 times t, v sub 0 is also going to be a constant. That's going to be whatever your initial velocity is. So if we look at differentiating this second piece, then we're just going to have that v sub 0 constant left over. That t variable will kind of drop out of there when we do that derivative power rule. Now s sub 0 on the back end is a constant as well. That's your initial height. So when we differentiate a constant, that just turns into 0. So we don't really need that portion on the back end. So the velocity function is -gt plus v sub 0. Now if I want to find my acceleration, what I'm going to do is differentiate that velocity function, which happens to be the second derivative of our position function. So as we're looking at this first piece, we want to remember that -g is a constant, again, depending on how we're measuring things. So if we differentiate this, then we just get -g as that answer, because that t will drop out of there when we use our power rule. And on the back end with that v sub 0, remember that's a constant as well. That's your initial velocity. So when you differentiate a constant, that just turns into 0 as well. So I'm not going to put that plus 0 on the back end. And then for our jerk, we're differentiating that acceleration function, which is the second derivative of the velocity, or it's the third derivative of your position function. Now, when we're differentiating this -g, we have to remember that g is a constant. It's a number. So when we differentiate that number, we get 0 as our answer. So if we're thinking about what's happening in here, the jerk is 0. And remember, the jerk was a sudden change in the acceleration. Well, if we're talking about an object that's just freely falling, there's not going to be any sudden change. That force due to gravity, it's always a constant force pulling down on it. It doesn't quickly change how much that force is at any given time. So that jerk, when you're talking about gravitational forces just pulling down, is always going to be 0. That's going to be it for this video. Thanks for watching.